Okay, good morning everyone. Thank you, Stuart. Yeah, my name is David Kerr and I am Shell's PTE for modularisation. I sit within our projects global discipline, supporting our projects in their execution, along with a range of other experts in construction and risk and quality and so on and so forth. I'm here today supporting Martin Swain, who is our construction digital delivery manager. So obviously he's got close ties in with COMIT. Just before I say anything, I have to tell you not to buy any stock based on anything I say. Not that you would. Okay, so how do we define modularisation at Shell? Modularisation is something that we've been doing for decades now. And I guess initially it's been driven out of a need to cope with installing facilities in really harsh environments, remote locations, and that sort of thing. But over time we've refined our thinking on that, and really we've got a new definition of modularisation, if you like, that's evolved over time, and that's really that we're seeking a more efficient execution. It's as simple as that. And to get there, what we're doing is taking advantage of off-site build to move construction work hours away from the work front, to standardise, to simplify the work, and then in doing so, we're achieving that efficient execution. So, up on the screen there, you'll see the aspects that we're looking at with respect to modularisation. First of all, we're looking to positively impact on the construction, so we're seeking the efficiency, the productivity, our cost outcomes, our schedule outcomes, our risk outcomes. So that's the main drivers, the main focus, if you like. And then we have a raft of other areas that we need to focus on in order to enable that to happen. So we have a whole scheme of methods of modularisation, be that precasting, pre-dressing of equipment, fabrication and assembly of different elements, whole units of process plant, pipe racks, all the way down to packaged equipment from specialist vendors. We also need to think about where the work's happening. So we have a project construction site, but then we have a whole supply chain supporting that, which includes specialist fabrication facilities, other supplier works. We need to think about where that's going to happen. Is it going to be in the country that we're operating, out of the country? Does it need to be off-site, near-site? What are the temporary facilities that support? Next, when you have a modularised execution, you have to think about transportation. So you have an installed design case, you know, what the asset is primarily designed to do, but then it also has to be designed to be moved from one location to another, which adds in a whole other set of design standards and requirements that you have to meet. You have to think about how that's going to happen, by road, by sea in our case, sometimes by rail. Do you need specialist jetties if things are being shipped over sea? Do you need other facilities at the site to receive your pre-assembled, prefabricated elements? Do you need specialist haul routes and other infrastructure at the site to enable things to happen, specialist lifting equipment and so on? With the impact that we're seeking to make in cost and schedule and so on, we can also derive other benefits, including safety, HSC, health, safety, security and environment. You know, we're reducing work hours at the site, reducing that exposure. We can have increased quality by performing work in a more controllable environment, such as a fabrication yard setting or a factory setting. Obviously, we're looking at process units and industrial projects, so we have a strong focus on commissioning and start-up and getting production going. So how can we support that? Ongoing performance of the asset. And then more and more we're thinking about how modular and really thinking about where something is constructed and the materials involved. We get into the sustainable and decarbonisation of construction as well, and how modularisation can support that. And then there's a whole raft of things that we have to do to make this happen, and a lot of it focuses on doing things very early. So within Shell we talk about the front end, and that's really all the work that needs to happen pre a final investment decision or pre-award, and we have a long set of stages that we go through in developing an initial concept, fleshing that out, and developing the design. And it's really getting the modularization thinking in very early in that process to set those design requirements such that it's carried all the way through. We obviously have to think about our supply chain and how that's going to happen from the earliest stages, and then we have our tools and systems such as advanced work packaging, which we lean on, data and digital, and how we're moving forward in the future. So, taking consideration of all that, we come to the realization, if you like, that projects are not modularized or stick-built, but there's an optimum level of off-site build in all competitive projects. So we go from the very simple, where we perhaps prefabricate some piping ready for the site, and we just reduce the number of welds at site, or precasting of small concrete elements, all the way through to the image on the right there, which is a whole process unit contained within a steel structure. So that's ready to be installed on its foundation, the final piping hookups, electrical and instrumentation hookups, and then it's ready to go, essentially, at least in theory. So that's basically everything in a box. It's a major MEI module. But the reality is that for most projects, we're somewhere in the middle, and it's about finding that middle ground. What's appropriate to take off-site and what's not? And if you are going to take it off-site, why? What benefits are you trying to derive, or what positive impacts do you want to make to the project? So just trying to put this into more general terms and take it away from a real industrial projects focus. In development of that early concept, we need to undertake a lot of investigations and collect information to identify what constraints we have about the site. And that goes from quite a coarse level in the yellow there through to more detailed investigations and assessment in the green at the end there. So things like labour and site attributes and schedule are all very important, and then we get into this sort of nitty-gritty of the layout and the design and what it is we're actually trying to achieve, what logistics and infrastructure and lifting that we might need, who are going to be our supply chain in this, what fabrication options we have, what supply options do we have, and then we get into the detail of route surveys and transportation studies and really understanding what can be done at a very detailed level. And this gets done very early in the project, even before the project's awarded, in order to make that assessment. So as I say, this is something that we've been doing with a range of success, let's say, for a number of years. Sometimes it goes very well, sometimes it doesn't go quite so well. We're always learning. We do have a lot of experience, but it's certainly always learning. So to translate this to a wider audience, what would we see then is when it does go right, what do we see as the key success factors? So an informed owner or client that's realistic and supportive and knows what questions to ask at the right time and get things going. A supply chain that's experienced and is also engaged very early in the project. I know that can be a challenge for some project types, especially when you have a separated design and build. But really, it does take that construction and modularization input as an initial input to the design to really make it work properly. Assessment, as I said, of the drivers and influencers and benefits around modularization and how that informs the design and your execution planning. A deep understanding of the constraints that we just spoke about, that early work in concept development and execution planning. And I think the contracting strategies, I think, is something that really plays into it. Firstly, collaboration, and ongoing collaboration, not just that you're collaborative once, but that you develop a supply chain and you keep going back to them and you both learn together over time. That's difficult to do, but where you have the best success is where that's able to happen. We're obviously enabled by the fact that we have integrated design, supply, build contracts, which we call EPC, engineering, procurement, construction. So that allows that construction thinking to really get into the design, something which in other project types with design and build are separated, it's much harder to do, but that's really a focus area. And then we have dedicated contracts for fabrication and assembly, and we have fabrication facilities which we go back to and we improve over time with. So we have that supply chain built up. And then finally, people, process, technology. You know, that's the same for any construction project. Really focusing on that work process, getting the technology in that supports it, and obviously having the right people, culture, behaviour all play its part. And then lastly, and most importantly, is a continuous improvement agenda. So it's great having a success in a project. If you can't bottle it and take it forward to the next one, you've really lost something there. Similarly, all the things that went wrong, if you can't work out what the root cause was and take that forward into your next project, then again, you know, it's not a lesson learned, it's just something that happened. So yeah, that's my presentation for you. I'll hand over to, who's next? Mark's next.
Just before Mark comes on, I just want to add what David said. It's not new; it's been around a while. One of my first projects was at the Shell Stanlow oil refinery on the Wirral, and that project had a number of challenges insofar as the programme was quite tight, and some of the concrete elements were enormous. There was no option but to modularise, cast the stuff on site, and roll it in with huge vehicles. To try and do it in any other way was just about impossible. And it's something you see more and more. I mean, some of the projects I've worked on, infrastructure projects, we've had beams cast for bridges, which because of the high quality requirements, means that they've got to be cast in a purpose-built yard and rolled in. And that seems to be, apart from Rico panels for bridge works, that seems to be the limit of where we've got to. I know there's other developments, there's other things that are being trialled, particularly with some of the contractors and national highways. But anyway, I won't spoil it. I'll bring Mark on, and maybe we can have a bit more of a discussion when we get to the session at the end. So Mark, thank you. That's for later. That's not for you.
Thanks, Stuart. I'm starting to regret not having a jacket, actually. So, my presentation's on here fine? Good. The video's working? I hope so. Okay, so if you haven't heard of Hexagon, or Hexagon Geosystems, which is who I work for, and Chris down here, who's the Director for Construction for Geosystems. Hexagon Geosystems is a software and hardware company that deal predominantly with geospatial data and what we can do with that. So I guess I should introduce myself. As you can see here, my current role is construction and engineering business consultant. And that means I work in a team of 4 or 5 that focus on building construction and how our technology can be implemented and help the industry. You can see I've got a kind of a varied experience as a surveyor and an engineer, and then actually spent more years, 14 years now, working with equipment suppliers and manufacturers in various roles, as in sales or training. So let's have a look at what at Hexagon we consider to be the life cycle of a building and the products that we have that fit into that. So there's a design and engineering section where our products can be used. Distribution, and it's very small on here. construction and renovation, and operation and maintenance. And these are all areas where our products and softwares can be used. In terms of modular construction, we have devices such as these. These are 3D laser scanners, which further on in the presentation I'm going to show you how these are applied and used within modular. Instrumentation like these, which are simply measuring distances and angles, but are used with very powerful software. Devices like these, which combine both. This instrument here, the MS60, laser scans and also does traditional setting out, laying out as well. All of our devices can be controlled with an iPad or a tablet device like this, running very easy to understand software, and you can see on the screenshot there it is advanced software working with 3D models. So I thought someone might have mentioned it already, or I thought maybe Stuart was going to put a slide up like this one just to remind ourselves of the benefits of modular construction. I think it's worth all of us just having a read of that and reminding ourselves that modular construction brings these benefits in quality, duration, to control your costs, program certainty. Of course, if you are building something in a factory, it's much more controlled. And of course, the big word, sustainability and less risk. So how do some customers use our technology? There's a company called Innovare, which were going to come today, but unfortunately they couldn't make it. But this is just an example of what they do. There's a short video here showing that. It's a bit unnerving not being able to see the screen. Is it working? So Innovare produce all the concrete, the panels for fascias and internal as well, all in a factory, and then they put it together like this. Quite simple, really. It's really unlucky that they couldn't make it, because they would have given a much better description and understanding of it than me. That's the future, isn't it? The best bit of the video is right at the end. There we go. So that's a company called Innovare. It's a French company. Obviously they do a lot in the UK as well. So how do they use Hexagon Geosystems technology? Well, you can start to see the technology being used in these 4 videos here. So we have a laser scanner, which you can see in the bottom right there. Oh, no, it's gone to the bottom left. They are using this in their factory environment and also on site. So in the factory, they can perform a verification analysis of the panels in the factory to check they are the right size and shape. And then when they start building on site and piecing the building blocks together, they can perform lots of other 3D laser scans to check everything is actually in the right place as well. And if there are any differences or they need to make adjustments, then those measurements, scans that are done on site can be communicated back to the factory and adjusted. Another example of a company we are working with at the moment, based in Northampton, are using the more traditional equipment, measuring angles and distances with the tablet you see there. And they are building, for a new building that's currently in progress, called the Sailmaker, that you can see in the middle. So in their factory, they've got a lot of steel frames working their way along, and as the steel frames are put together, they're using the equipment to verify the position of the frame and everything is square and as it should be. Then moving forward, because they're quite new in using our technology, they've only been doing it for the last 3 or 4 months. They're going to start to use the technology to then verify the modules that have been put together internally with the service after the services have been put in as well. But as you look at the top left there, you get a feel for how straightforward the software is to use on the tablet. We can see a 3D model of the frame. And actually this is an interesting one, because if you look in the bottom right, when I was there and training them, showing them how to do it, they actually found an 8mm error in the verticality of one of their beams. And straight away they were like, yes, we love it, we're going to hire this equipment, we're going to look to buy it as well. They're currently still hiring it and using it, and they're finding lots of kind of errors around 8mm, 10mm, and far better to find those errors in the factory rather than on site. Another example of how our equipment is used on site for verification, for example. Okay, this isn't a module, but this is a lift shaft that has been put in. Our equipment can be used to scan the lift shaft after it's been put together for verification. And in this example, this could be a floor, this could be a whole room or a wall. The same software does the same thing. And we found in this example here that the top of the lift shaft there was leaning over 40mm at the top. So this process of verification using our equipment can be done in a factory environment or on site. So this is just a short video to show you one of the bits of equipment and the process of performing the verification of a floor. Is something playing at the moment? Has it skipped it? Are we on Wi-Fi with this? It's online. I think that particular video went to a YouTube. I'll try it one more time. Okay, we'll skip past it. So what that video is supposed to show was just the equipment being used, scanning the floor, produces a heat map, and then without leaving site, the equipment shows you where the out of tolerances areas are on a wall or a floor slab. And you can still scan the floor slab even when it's wet, which is quite interesting when the concrete's wet. Then the equipment will point with a red laser to where the out of tolerance areas are, and then they can be remedied. Here are some other examples of verification with the laser scanners being used there to verify the as-built structure. And the laser scanner is working with some software, some office software as well, called Cyclone 3DR. So in this software we can perform further analysis, and you can see verification of the structure there in the slide you're looking at. I think, as you can probably work out there, the data that's being collected, the measurements, are being verified against a 3D model. There's an example of floor flatness. And moving on from that, we can see our equipment being used in M&P as well, because the equipment generally across the industry, our geospatial equipment, is becoming easier to use, much easier. And we're starting to find, well, we're doing quite a bit of work with MEP contractors now, which traditionally would be using tapes and strings, but they now feel that they can get involved and start working with 3D data and using the equipment themselves to be much more sustainable, saving much more time. As we can see in the screenshot here, we have a 3D image of those hangers to put up for the MEP. And I think in my text, I can't read it, it's so small on here, but I think it says they were had done the work they were doing in 20 minutes. I think it says it would have taken them 4 hours normally. So a massive time saving. Stuart mentioned already the blue and the red. I think you're a red man, aren't you? You're not. So this was all right. Okay. What is our technology doing at the new Everton Stadium? So Stuart talked about they have a big factory where they prefabricate a lot of the parts of the stadium. Where does our technology come into that? Well, one part is QR codes, which is, everyone's familiar with them now. It's quite a simple thing, really. So we've incorporated QR codes into our softwares. What this means is that when they're making their elements in the factory, they are putting QR codes on them. The QR code relates to the IFC, so the 3D model. The QR code is for a particular object, so it's for this wall over here, or it's this staircase here that's being brought to site on the back of a lorry. What does that mean for our technology? When it arrives on the back of a lorry, it has a QR code on it. The engineer, the site engineer using our equipment, can just hold up the tablet, scan the QR code, and then on his 3D drawing, as you can see on the screen there, it will highlight where that element goes. So the engineer knows where he has to go to get it in the right place. The truck driver knows where it's got to be taken. It's all a very smooth process. They're also making a lot of use of background imagery, which again sounds simple, but this is all time saving and not making mistakes. It's trying to take away kind of a human error element of it as well. If you've got a background image, you know where to go. What you can't see from these images is that is actually a 3D model, but we're looking top down. So you can have the background image and the 3D model all in one 3D orbit as well. Sticking with Everton, I think this video should work. There we go. We've also demonstrated our BLK2 arc at the Everton Stadium as well. So you might notice on this, we call it a carrier. Everyone calls it Spot the Dog, but we want to focus on the hexagon technology, don't we? Not the dog. You might see at the front of the dog, it has one of our laser scanners at the front of the dog. So what's good about this is that when work has died down, or after everyone's gone home, the dog can be pre-programmed with routes to walk around a building site on a particular floor, and it will collect the 3D laser scan as it goes round. And this is great for progress reports. we go. And we've had some really good feedback as well from our technology being used there. So what is all this technology doing? It is, for us, a massive drive towards sustainability, like for everyone, is a really huge thing. And one way that we help with that with our softwares is automation. A lot of our software is doing a lot of things automatically for the user, whereas if you went back 10 or 20 years, softwares then were having the user make all the decisions, whereas a lot of automation is very fast now in the software, and this is all helping being faster and taking away the human error element as well of construction workers on site. And that's the end of my presentation. There is another slide, but it relates to your questions you're going to ask me, I think.
Yeah. Thank you for that, Mark.
Right.
Thank you. We are a bit short on time. What I want to do is condense the questions. I haven't got some more questions. So, can I invite David to join us on the stage? Put one chair to one side and just push one to the back. Okay. Yeah, that's fine. Yeah, absolutely fine. And I'll stay in the middle. Yeah. So I'll turn to my left and turn to my right, and yeah. Okay. So I've got a number of questions, and the first question I want to ask is, what a great presentation, by the way. I mean, to bring this out and show some real examples, I think is great. So thanks, Mark, for doing some real life stuff, and thanks to David for giving us the vision, basically, and sharing some, thoughts and ideas about, what we should do and how we should do it. I've got a quick question. You mentioned QR codes.
Yeah.
We use a lot of QR codes. Why not RFID chips, tags?
That's a good question.
Yeah.
I don't have an answer to that.
No. Okay. Something to think about.
I'll ask our friends at the factory.
Yeah. I mean, QR codes are cheap.
That's the thing with a QR code. You can create your own QR code. You probably realise
You do it
yourself
right away, yeah.
easily. Yeah, there's websites where you
Yeah,
can create
yeah.
it free of charge.
Yeah. I mean, there are pros and cons, but I've got your questions there. I mean, basically, what is the hold-up? I want to just ask questions. Just bear with me a second. I've got one in particular. So I'm going to ask both of you the same question, but it's going to be less applicable to you than it is to David. So my first question is, what can respective organisations do to increase the use of modular on the projects?
Okay. Well, I think there's almost a maturity element to it, I guess. So, I think there's the demonstration of what's possible, but then I think there's demonstrating experience within your segment, if you like, or your part of the sector, such that designers and asset owners know what's possible. I think there's just a lack of knowing what's possible. So obviously Shell have been doing modularisation for a number of years and have built up a supply chain and know what's possible, and to a certain extent we have archetypes around, although our projects are quite unique, there's archetypes around the way things are designed and an expectation on how that's going to be performed. I think with the successes you saw, like Everton Stadium there, I don't know if that is, you say it's been made in a factory, but is that a factory that existed before, or is the factory being made for the project? So if you're doing something for the first time and you're having to create the facility to do it, then they've modularised to solve a specific problem. And will that factory exist once they're finished?
Yeah.
So if that supply chain disappears, then it's no longer an option unless the next project comes along and builds it back up again. So I think that sort of supply chain maturity, knowledge across the supply chain, understanding the design concepts and as they apply to, say, stadia or rail, other types of infrastructure, roads and so on, and then sustaining that over time really helps the market grow.
To answer that question, it is purpose-built. Sorry, the factory is purpose-built. It's not. The steel factory is, though.
They've got multiple factories.
Right, multiple, okay.
Northern Ireland have been part of the supply process for over decades.
Right. Okay. So, a mix. Okay, thank
Not,
you.
not sure I answered the question there, but
No, you did. That's a good start. So the next thing I'm going to ask is, and again, this will apply more to you. What's in it for us? Let me ask you.
For us, well, we all want to drive the sustainability issue, don't we? What's in it for us is that I've mentioned human error a few times there. It's not making a mistake and wasting materials. For me, it's all about sustainability, getting things done efficiently, more safely. Everything that was on that slide I showed earlier, really, about what the benefits were of modular construction. Yeah.
Okay. You've already explained it, I suppose. But going forwards, on the horizon, is there more modular projects planned?
well, certainly within Shell, it's something that's looked at more and more often. I think the benefits is one thing, and but I think when it comes down to whether or not a project gets the go-ahead or a design gets sanctioned, it's really about, can you demonstrate the cost benefit or the schedule benefit, because that's what gets it going. So I think, again, it comes back to, can you develop a concept and then do an estimate against that and demonstrate that doing something away from the site as opposed to on the site is better for cost and schedule. And I guess that's another stumbling block, because it's notoriously difficult to estimate something where you have no supply chain to back it up yet.
Yeah, yeah. There was, when we were putting the questions together, there was a bit of to-ing and fro-ing, and what I was trying to do was get a client's perspective, a designer's perspective, a contractor's perspective, and a solution provider's perspective. And that's largely how the questions were made up. But one of the things was, and it was suggested, to get more of this in place was to have it specified by the client that we must do that. But it comes back to the problem, have you got the manufacturing facility available to do it? With certain components on a project, you will have. But when it comes to concrete components, and forgive me for not having it fully correct, I understood the concrete components for those two stadia were being made in the north somewhere and brought in, but I suspect there's a mixture of stuff that's off the shelf and purpose made in that factory or their factories. So specified by clients. The other question I've got is, how do we get the supply chain further down the line to buy into this? Because there's going to be other components that we could essentially purchase. How do we do that? David, any thoughts on that one?
Yeah, that's getting a little bit out of my area of expertise, but I guess you're taking the work off the site and you're putting it somewhere else. So can the rest of the supply chain support that new facility? So it's, so the work still exists, but is the supply chain and the workforce, the required equipment available at the fabrication facility, let's say, whatever it is, the assembly facility. So I think there's perhaps an expectation that people are going to be on a construction site, and that's the way that things are geared up. Yeah. But if the same people, let's notionally, were able to be put to work at the fabrication facility, then maybe it wouldn't be seen as such a great leap. It's just that that's the site now. The site is this control point, not the actual project installation site.
Okay. Let me put it out to the floor. Let's ask the audience. Any thoughts on how we can get the supply chain? Jerry.
Back in 2006, I was working on a case study for Terminal 5 Heathrow. So that was completed in 2008. And why it worked with the off-site assembly was because they were partnering and all the key partners were brought in at the beginning. So it was Crown House Engineering and their major supply chain. And they had, I forget the figure, but there was a quite high percentage that had to be off-site assembled so that it didn't impact on the people that lived on site, the people that worked on site. And I had to monitor how that progress was going. But it's because they were all brought on early on.
Yeah.
And I don't see how else it could be done unless it's kind of a true partnering contract.
Sure.
With strict.
So specified then.
Absolutely, from the
okay.
outset.
Let me ask Graham. Graham's just finished on HS2. You'll have seen potential opportunities there. How did HS2 as a client handle or create an opportunity?
It relates back to the design. So and then, as we said before, being able to produce cost schedules and program that show that using off-site manufacturing is better for, as we say, quality, health and safety than building on site. HS2, the EKFB works, we're bringing in manufactured concrete products to create the tunnels. So we're manufacturing off-site, we're bringing it in very, very early on Sunday mornings, closing roads. To me, the main issue with off-site manufacture is still transportation, getting the stuff from wherever you're building it to the site.
Is that because it's too big?
There is the size of the roads that you have to use. The roads that we're using particularly, there's a lot of small roads. Getting the items to the site is a problem. And that's, you need to manufacture to the size of the logistics that you can actually use. If you can't get it there, then it's no use.
Okay, thank you. Have you any thoughts, Mark?
No, I can't see my slide, but
You can't. I've made it as big as
what I wrote
possible.
was okay.
Yeah, no, it's brilliant. It's brilliant. So I think we've got a taste of why it's taking so long. But sorry, another question, Max. Go on.
Just a quick one again. You talked about using the QR codes on the equipment.
Yeah.
When we were producing tunnel segments for Crossrail we had an old oak construction facility where we were using that. One of the biggest problems we had was actually making barcodes, as they were there, stick onto the concrete. Now, it sounds very, very simple, but we tried all sorts of things to make the barcodes stick. Now, I don't know how you do that with your QR codes, but that was one of the main issues that we had.
I don't actually know how that contractor's doing it. Chris, do you know, are they putting glue on?
We tested quite a number of different glues to see whether they would stick onto the concrete and stay on the concrete when they were stored and then moved and effectively. So that was it sounds very simple, but it was one of the issues that we had was keeping track of everything that was there.
Okay, if I take your details, I'll find out. I'll let you know.
If I could add to that. Question earlier about QR code versus RFID. RFID would have solved a lot of those issues because you can just literally push it into the wet cement, and because it's remotely activated by the reader, when you wave the reader over it, it excites the RFID, at which point you would have got around that issue with things falling off. However, when you're trying to stick RFID to steel, it does block a lot of the signal. Same with aluminium, so that might be why you're not using RFID with your system.
Yeah, there could be. There could just be a cost element to it as well. I'll find out because I'm sure someone at our factory has looked at all the options before.
Okay. Before we wrap up, is there any more questions? Tommy?
Yeah, I just have one more. If everyone decided to switch to off-site, I know there's a balance of when you would and when you wouldn't, but if everyone did decide to, go towards off-site, I would expect there'd be some sort of shortage of availability of manufacturing resources. How would we overcome that? You know, it's a bit chicken and egg, really, isn't it? Because you need to show the demand before you invest in the facilities. Something's got to be done along the line there to make that happen, to try and promote that to happen, to incentivise it in some way.
Yeah, I mean, I'll answer that first, if I may. So, when you're setting these projects up, I've been involved in early contractor projects, and looking at opportunities, I think is one of the early things that's examined. David alluded to bringing the EPC along early, and I think that will be one of the risks that's flagged up. And you'd put measures in place early on. I mean, I mentioned about a project I was involved in, where if we'd done it traditionally, I know full well that it would overrun the period, the contract period. But because we were able to put things in place, we had time. We had time to plan. We had time to organise and execute according to the programme. So I think it gives opportunities. Certainly, you know, if you've got more time to look at things, you've got a chance to, you know, put things in place. There is a shortage of people in the industry, regardless of what you're trying to do. I mean, contractors, as you probably know, contractors' success rate has improved dramatically in the last 3 years. I mean, contracting used to be, if you won 1 in 4, you were doing really well. Now the success rate's much improved on that. Some are winning 1 in 1 and having to turn work down because they haven't got the people. They just cannot get the people. So, sorry, go on.
Maybe I could just add something there. I mean, the stadium examples there is good in terms of showing you what's possible, but I think to build up a supply chain, you have to show that there's a funnel of projects coming. So where's that? You know, so you look at commercial office space, retail spaces, schools, hospitals, things that get periodically knocked down and rebuilt because they come to the end of their life. You know, there is a funnel of projects there which will sustain over time, and you can envisage that they can have module concepts or archetypes which can be reused. You know, they're not one-off designs. That's only, you know, you're only going to build one new Goodison Park, aren't you? And that's going to be it for the next 150 years or whatever, or however long it lasts. But you know, you might build a new school every 25 years, something like that, for a town. So there's a funnel there, and you can demonstrate the throughput. Then the supply chain will step up because people will see that there's okay, they're going to build 50 new schools over the next 5 years, for instance, and they're all going to be modularised, and they're going to need a factory, and someone or a number of people will step up and fill that gap. So I think it starts from who's spending the money in the first place, and then it trickles down, and you know, it's forums like this which will inform asset owners, whoever they may be, governments, local authorities, show them what's possible, and then it starts being taken forward. It's like a communications campaign almost.
Yeah, absolutely.